Don't you hate it when you read in a data file and it's got a lot more columns than you actually need, and the column names are maybe rather cryptic? This week, we're going to look at some handy tools in Pandas to help us clean up our data frames and make them nice and easy to use. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. On this week's MetPy Monday, we're going to continue talking about Pandas and some of the great things that it can do for you. And we're going to specifically look at dealing with cleaning up our data frame columns. So let's go ahead and get some data in and look at the problem. So we're going to import Pandas as PD. We've been doing as standard. I'm going to specify the same data URL that we used last week. So this is just a day's worth of data from the Norman Mesonet station of the Oklahoma Mesonet. And then we use the read CSV function. We pass it our data URL. Remember, Pandas will go out and just download that for us into memory. We need to skip 2 rows and use whitespace delimiters. One common mistake when people are following along with videos is not capitalizing the T or the F in the true or the false. And notice how when I do that, it turns green. That's a Python keyword or reserved word. So if you have a lowercase t out here, you'll notice it doesn't. So that should be a clue that something is incorrect. Python is case sensitive. If we look at the head of that data frame, we see the first 5 rows and some of the columns. I've showed you before that there's a columns attribute that has the names of all of the columns. Now you can directly edit this, and we will do that in a little bit, but I want to show you some easy ways to manipulate this. If I just want to make a pretty standard plain plot of our regular atmospheric variables, temperature, pressure, humidity, wind speed, wind direction, and rain, I don't need a lot of these columns. So we can drop them. The easiest way, since there are so many, is we're going to copy this. And then on df, I'm going to use the drop method. And you can drop in more advanced ways. We're going to look at just dropping an entire column for now. I'm going to paste this in and remove the things that I want to keep. So I want to keep time, relative humidity, air, wind speed. So I want to keep those things. I want to keep wind direction. I want to keep rain and pressure and solar radiation. And everything else I'm okay getting rid of. So I'm just going to do some line wrapping to kind of clean this up a little bit. It's always nice when your code is neat and readable. Okay, now if we run this, it's not going to necessarily do what we think. I'm going to specify that we want to do this column-wise, so I'm not trying to drop the index stid or stnm, I'm trying to drop the column named stid or stnm. You can use axis 0 and 1. I think using names, index, and columns is a lot more straightforward. And then we're going to say in place equals true. That way we don't have to say df equals. It just modifies things in place. So if we run that, and now we look at df.head, we only have a few columns. We've gotten rid of all that other data that I'm not interested in, so there's no need for me to manage it. All right, so if we look at df.columns again, I just have these. I'm going to copy these, and I want to rename them because these are short. They're not that cryptic, but they're short names. I want to use a long descriptive name. Also, when I'm plotting, I can get automatic legend population a lot more nicely if I have long descriptive names. So I'm going to create a dictionary called name mapping. And though I generally don't like copying and pasting, when you're using strings directly like this, it probably results in less typos, in my opinion. So the key is going to be the existing name, and the value is going to be the name that I would like it to have. So I'm using longer names here. If you're not familiar with dictionaries, they're basically a hash map. You might be familiar with that from other languages. But we've done some videos on these in past MetPy Mondays. Basically, we can look up by the key, so WSPD is going to return the value, wind speed. It's a lot easier than managing a couple of lists or a multi-dimensional array or a list of lists or something like that. It's a really nice data structure and one that I didn't use for my first several years programming Python, and one that I really enjoy using now. So we're almost done. We've just got SRAD, which reads a lot more nicely as solar radiation. So we could go through and write a loop that loops through each of these things and tries to find them in a list or tries to find them in the dictionary, but Pandas already has this built in. We can call df.rename, and we specify that we're going to rename the columns using our name mapping dictionary. And again, I want to do this as an in-place operation. Now if we look at df.head, those have automatically been replaced. The cool thing here is I could have had more names here. So I could have said something like maybe stemp on some stations is soil temperature. It doesn't error out. So if you have extra keys in there, it will just ignore them. If you have a column in your data frame that is not in this name mapping dictionary, it doesn't touch the name, it just leaves it. So this doesn't raise errors easily. And I think this is really great for maybe you've got several different data sources and they have different names for their air temperature column. You could put all of them in one name mapping dictionary and use that same name mapping dictionary on everything. It's very, very convenient. Now I mentioned that we could go through and modify that list in the columns attribute manually. So let's show how to do that. Maybe I need all of these to be uppercase. I'm going to do some sort of string comparison and I'm going to cast everything to be uppercase or lowercase. I would say title case, but we've already made them that. So I'm going to call df.columns. And I'm going to set that equal to the result from our list comprehension here. So I'll write this out and show you what it does, and then we'll go over exactly how it worked. So now you see everything is uppercase. So what this did is for every column, for every element in df.columns, we called call.upper, put that result in a list, and then reassigned it to df.columns. This is the same as saying for call in df.columns, and we need to make a result array here, our result list rather. Res.append call.upper df.columns equal res. So these lines do the exact same as the list comprehension above, but it's 4 lines of code versus 1. If you're not comfortable using list comprehensions, that's okay. You can go ahead and write the 4 lines, but you will see these in other people's code, and as you progress using Python, you'll probably get more comfortable and grow to really like them for their conciseness. So you see there are pretty easy ways to manipulate columns in your data frame. Throw out things that you don't need, rename them to sensible names, and then you can start working with them. And in fact, as we continue our Pandas journey, we're going to look at how we can take multiple data frames and start combining them. We have multiple data sources, and we want to merge or join or concatenate 3 separate but similar operations. So we'll start looking at those on next week's MetPy Monday.